Okay, question 2. We have a total cost function of q squared minus 5q plus 17. So this is not a straight line, this is a quadratic. It's going to be a curve that's vaguely that shaped. First, we're asked to complete a table. So here's our table, q. We've got 0, 1, 2, 3, 4, 5. We've already been given. Aren't they nice? Or aren't I nice? Already been given 3 values. We need to find the others. So what's all this about then? This is saying that for these particular values of quantity, what will be the value of total cost? So this is like our recipe. This is our function. If we're given a value of q, we can insert them and find the total cost. So let's do that. So first we're looking at where the quantity is 0. What is the total cost when quantity is 0? We know there's always going to be some cost even before we've produced the first item of product. So we are going to substitute in 0 wherever there's a q. See, everywhere there was a q, there's now a 0 because that's what we're investigating, the value of 0. What that does to total cost, and it does this to total cost. And 0 squared is 0. Minus 5 times 0 is 0. So it looks like the total cost when quantity is 0 is 17. Stick that in there. Now we need to do it for when quantity is 3. So we're going to put that in. 5 times 3 plus 17. See, wherever there's a q, we now get a 3. So 3 squared is 9, minus 5 threes are 15, plus 17, and that is 11, I think. That's 2 plus 9 is 11. So we have another one there. And finally, we just need to substitute in a 4. So when I put the 4 in brackets, it's just like a bookmarker. It's saying it will be a 4. 4 squared 16 minus 20 plus 17. That's minus 4, so that's 13. So there goes a 13. In fact, we can see a bit of symmetry going on here, can't we? All right, so that's part B. No, that's part A. We've done that. Part B, we now have to use the table to roughly plot. And when they say roughly sketch, we're not expecting to go too accurately. Roughly sketch with, okay, so we're told we're going to have Q on the horizontal and TC on the vertical. That's normally the case. And we need to find these. Sometimes in an exam, I give you a bit of hint of where to start numbering it. But if you look, Q goes from 0 to 5. So we can sort of do that. 1, 2, 3, 4, 5. Not very accurate, but accurately enough. Total cost goes between 11 and 17. So they're the only numbers we want. If you're somebody who likes to start at 0, that's fine. We can say that 10, that's 20. Actually going to be a rather shallow curve, but that's okay. So look, when quantity is 0, total cost is 17. So it's about here, isn't it? When quantity is 1, total cost is 13, so that's about there. And then at 2, it goes down to 11. 3 is about 11. This goes back to 13, and that goes back to, there we are. Oops, that's a bit too high. So that's our curve. If we wanted to show more of an exaggerated curve, we could have started at a number other than 0. Say we could have started at 10, and we could have gone to 20, and then it would be a little bit more of a nicer quadratic curve. Right, so we've done that. Part C, we need to find the average cost function. So if total cost is q squared minus 5q plus 17, what is the average cost? So this is the total cost. Average cost that's when we look across all of our production, what's the average for each one. So all we're really going to do is divide this function by Q. So if we take the total, we divide by Q, we're going to get the average. Yep, we're averaging it out over every item. So minus 5Q plus 17. We can draw a long line and put a Q underneath if we want, but it's much easier just to divide each term by Q. Now, if we've got Q squared divided by Q, the answer to that is Q, because that's Q times Q over Q. Those cancel out and leave a single Q. Now here the Q's cancel out. I say cancel out because I'm multiplying by Q and I'm dividing by Q, so they counteract each other. And then I get this problematic thing at the end, but not your problem, just 17 over Q. That's all we want. That was part C. Part D, find the marginal cost. So now we're talking differentiation. That's how do we find the marginal cost? We differentiate. Let's start from this again. So marginal cost is going to be equal to the dc by dq. So we can write it any way we want. Lots of ways we can write this, but we're going to differentiate total cost to get marginal cost. So you remember we differentiate, we multiply by the power, reduce the power by 1. If we've got just a 5Q, it becomes 5, for reasons we went to in class a few times. That started off with a 1, and that became a 5, and then that became a 0, so that just disappeared for a 1. Constants disappear during differentiation. So that's part D. I should be numbering these really, shouldn't I? So this was part C, this was part B, and this is part D. And the final bit, E, find the exact level of output at which total cost is at a minimum. So here's our E. How do we find the minimum or the maximum of a curve? Well, the answer is we find the marginal product, or the marginal cost, whatever it is, the marginal function anyway, and we set it equal to 0. And why do we do that? That's because at the minimum points, the gradient is 0. And the marginal function always gives us the gradient at any point on the curve. But we're saying, tell us the value at Q at exactly the point where gradient is 0. So we take this gradient function, this marginal function, set it equal to 0 because it ekes out the value of Q at which the gradient is 0, which just happens to be the minimum or the maximum point. So we want to get 5 over to the other side. Remember, every time we change a term to the other side, the sign changes, so it becomes positive over there. We've got 2Q equals 5, but we're not interested in 2Q. We're interested in, oh, it should be a 2. We're interested in 1Q. So we divide by 2. We divide by whatever that number is. They cancel out and we get Q equals 2.5. So that tells us that, so going back to looking at E, so the minimum cost happened when Q was 2.5. But of course, that's not the minimum cost. That just tells us how many, what the quantity is at the point at which the cost is minimized. So this could be 2.5 units, it could be 2.5 million, it depends. So what we want to say then is what's the, find the exact level of output. Oh no, I was going to take it a step further, but we don't need to because the question doesn't ask us for that. If the question asked for what is the total cost at that minimum point, we would have to substitute that into that, but we've finished this question.